we see time and time again that nation state actors are really have woken up to the fact that software update attacks are extraordinarily effective because anyone, you have a situation where for most of them, it's a client makes a connection that's usually over a secure channel like HTTPS to somewhere they're supposed to be going and retrieve something and then runs that thing after they've hopefully verified it in some meaningful way. They run it and install it often as root. So when you look at historical high-profile attacks by really, really good, by top hacking groups, which are nation-state actors, time and time again, we see software update vulnerabilities being used as part of this. So when Israel and the US allegedly wanted to go and take down Iran, they used Flame and Stuxnet. And in particular, Flame was the result of multiple software update vulnerabilities and was really the more interesting piece of malware than Stuxnet, which gets a lot of the press. When you look at Russia going and hacking power plants in Ukraine, or the NotPetya attacks they went through to attack MEDOC and others like that, those were all via software updaters. When you look at North Korean attacks on South Korean banks and infrastructure that caused $750 million worth of damage, it was via that. And one thing that people often think when they think about the problem is they think, well, I sign things and I check signatures, so that's sort of enough. And it's not. So if you look, the slide you're looking at now that Erica has displayed now, or no, sorry, that Howard has displayed now, these are all major tech companies that have had their users attacked via software update vulnerabilities. And I could literally cover this slide with much smaller logos from a much broader set of companies, but I think I kind of make the point here. These are some of the companies you think about as having the best security teams in the world. And I could add, once again, I could add a bunch of others on here. So it's definitely not as simple as just sign it, and then if it's signed, it's okay. You have to have a mechanism for verifying that an update you're getting is not just signed with the right key, but you have to have mechanisms to make sure that the update is actually timely. So way back in, 2007 or something like that, I set up mirrors for a bunch of popular Linux distros, and I could get them to happily accept copies of SendMail that were 5 years old at that point, that had massive known vulnerabilities. And I could convince any client that came to those mirrors to go and install those by telling them in metadata, hey, this is what you're supposed to install. So those sorts of vulnerabilities and other vulnerabilities like it are a real problem. You also have to handle things like key revocation. So when a compromise does occur, how do you survive it? What do you do? And that's really what TUF is all about. So TUF is a security framework that really has thought through how do you handle issues like resisting compromises. When someone goes and breaks into a server, how can you make it be that you're able to actually recover from this without just going and, for instance, signing an update that says, hey, trust this key instead of my old key, which was compromised. Because if you do that, then users don't have any way of knowing whether this new key you're giving them is secure, or whether it's one that the attackers have gone and signed. And TUF also, one important property of it is it also slots well into existing setups that people have. So if you go to the next slide there, so we try to support the kind of infrastructure and setup that people have, so that we're not telling you must have a man trap with biometric access and laser lights over the the ventilation shaft leading into it, Mission Impossible style, or anything like that. People are able to go and deploy and use TUF in a lot of different scenarios, and they're able to do this, and they use it in very slightly different ways, but they still, get these properties where they can go and actually revoke trust and keys and so on. And so it's the kind of system where you typically set it up once in your infrastructure, and that takes you, a little bit of time. It's not painful to set up. But then the day-to-day things you do, operators basically don't notice the pain and problems. And I could go through the next few slides if you're curious about this and talk about why TUF works this way and how it works. If you want, I can discuss that. If you don't, if it's not useful, then I can also skip that and talk more about where we're at with TUF or other things. Like I'm happy, however you want to use this time, you let me know.
I'm pretty familiar with the TUF design. Howard, do you need an overview?
I think we can skip some of the details.
Okay, so why don't you skip ahead a few more slides? I'll just give you a couple quick things about where we're at with TUF. Yeah, that's a fine one. So we have a bunch of standardization process and so on. TUF is actually quite widely used outside of the cloud native space. In fact, I'm leaving tomorrow to go to Detroit to give a talk. I think it's our 10th workshop with automotive folks, the 10th Optane, which is the TUF variant for automotive, and we're finishing up IEEE ISTO standardization. We've already had automakers from about a third of the cars on US roads pledge that their new cars are going to be using TUF, and we have tentative, we are planning to have this used in future cars from even a broader set of automakers. So we're kind of hoping that we get things moving along there. We've also have folks in sort of the more language package manager and other spaces like that using TUF for a variety of different things. So, and the most popular, there are a couple of implementations of TUF that are used in the cloud native space. Our reference implementation of TUF is used by some of the cloud native folks who adopt it, but only maybe a fifth or a quarter of folks in the cloud native space use that. The most popular implementation is actually Notary, which is a Go implementation that was done by folks at Docker and is available under our organization as freely there. And there are some differences with Notary. It does things with Docker Content Trust that deal with the way they do trust on first use, which is different than how some of our folks who deploy a reference implementation do it. And I can answer some questions about some of the Docker Content Trust differences if you're curious, but I think the main thing to really know for this talk is basically Notary is a Go implementation of TUF. It's the most popular implementation in the CNCF space and one of the most popular implementations overall. And yeah, it has added a few things kind of around the edges, but is TUF in the core.
I was actually gonna ask a question regarding the automotive industry. I remember there's also an open source project in NYU doing a OTA security. Is that team related to the TUF?
That is. That's me and the same people who work on TUF working on it in the automotive space. So,
really?
So the main developer on that project's name is Optane, and I can show you slides from that too.
Yeah.
So here, let me give you.
I really like Optane. I think it has a really nice.
Yeah, the document was amazing. So you guys are from the same team, right?
Yep. It's
cool.
So I'll make I'll share a link in just a sec.
I'm quite sad though. Anytime I share it, people see it's something automotive and something with other components that they don't think about and therefore ignore it. So.
Yeah, that does happen. Yeah, actually, I mean, Optane is basically just a TUF variant that works for automotive industry. And I'll give you slides. I don't know how much we want to go through that. Here I can. I'm happy to, once again, like I view this as there we go. I've posted it. I view it as I am happy at this point to talk with you about whatever is most useful. So if you want to talk about that, we can talk about it. If you want to talk about in toto, however you'd like to go through it.
So a couple of things. I have questions real quick. With it, what has been, in your experience, the biggest barriers to adoption, specifically within Kubernetes, of a more robust kind of?
I think it's that people don't, I don't know, because we have a fair amount of adoption. I think it's largely that end users don't have to touch us really very much at all. And so they don't, or not end users, but like the DevOps folks don't really like play with or manipulate all this. This is all kind of behind the scenes. So a lot of times we have to wait for the folks that have the infrastructure to decide that it's an important thing for them to address. And to be, you know, the good side of that is that, well, we have had folks, you know, throughout a lot of the major cloud infrastructures go and say, hey, this is important. Hey, you know, Microsoft Azure folks, we think this is important. We're going to go and add this, you know, and, you know, as these different adopters from IBM and Red Hat and, you know, all these other, like, you know, really security conscious folks get their eyeballs on it, I think that they adopt it and they don't see it as a big hurdle. I think one thing we've had is sometimes people look at it and they say, gosh, it sounds like when you look at it on slides, it seems really complicated. But it's really simple once you use it. Like, once again, it's kind of a setup sort of thing. It's a little bit like if we had all the state diagrams for like doing SSL and TLS SSL, and then, you know, and then people thought they had to implement all that rather than just using their URL lib library and putting an S there and maybe giving it a certificate bundle. So it's, I think overcoming that barrier has been the biggest thing.
Okay.
Are there like extra requirement for the infrastructure to support TUF or like TUF-based implementations?
Not really. I mean, you basically have to sign things that you might not be signing, or sign them with keys that you might have to generate like an extra set of keys you use to sign something. But it's like, that's automated setup usually. I mean, you should be signing your software, your images, whatever it is, your containers, whatever you're distributing, you should be signing them in some way. And assuming you're doing that, you are probably just generating slightly different metadata than you did before, which TUF does for you. So it's mostly a matter of just setting things up. Now, on the repository also generates metadata about like what are the set of things on the repository. And pretty much all repositories do this anyway, but they sign it. And they sign it using a different key than they use to sign the packages and things like that themselves. So in practice, we haven't really had any problem with people adopting TUF once they went in and actually looked at it. No one's come to us and said, we tried to adopt it, but it was hard. Everybody said this was easier than we thought it was.
Is there any requirement for like TPM or HSM support for like key management?
No, we don't require, but we do support several of those in our reference implementation. And I'm not sure which ones are supported by Notary. My understanding is they do have at least some support as well.
Okay.
But none of that's required. It is supported. So, cool.
Within Kubernetes is mostly dealing with images, right? There's two places that this sort of enforcement can happen. One of them is at the admission stage at the API level. And this is what I've seen. Certain, I think Target has something that you checks, or is it IBM checks the notary signatures at the admission level. And the next level is the one that people generally think of, which is closer to the runtime of you're not going to run something until that runtime has verified the signatures. And that's the area I haven't seen as much movement in. Is the security difference there significant enough that that should be something we push harder on? Or do you think the API level is a good enough place to check this sort of metadata signing?
Okay, so I'll say that this is a question I would like to bring back and chat with folks about, but I'll give you my off the cuff. So treat this with not as being like an authoritative answer, but as just my intuition is that if the I don't think there's a long time between those steps. And if there's not a long time between those steps and there's not a substantial opportunity for things to change between those steps, then I think that it doesn't matter so much where you do it. But it's super fast to do the check and it's not particularly hard to do so. So I don't see a reason not to add it. I don't know if there's like like cases related to cross container attacks or something like this, or like an agent on the system, overwriting parts of a container image or something like that would be caught here. I don't know. Am I out in left field about this, Erica?
I don't think so. Hold on. Yeah. I'm trying to figure it out. I guess one of the problems we're having, there are situations where that kind of overwriting and cross container is a big concern. If you ask the people at Red Hat making the container runtimes, they'll tell you probably that SE Linux protects you from it, from any of that kind of thing, which is probably theoretically true. But in general, people are very worried about container states are crossing boundaries, especially because like oftentimes you have a privileged container next to a less privileged container, for instance, for like Istio. So those are.
So it might help, but I think we'll still fundamentally always have a race condition where TUF might do a check right before, unless there's some way to make the thing it's checking immutable and then check it. And then, maybe if you could do that, if you could make it immutable, check it, and then instantiate it, then you would get additional benefit from that. But I think you get even, so that's interesting. And there's no reason why you can't do that actually quite easily with TUF. I think in fact our reference implementation already supports this sort of checking you could do a check without update effectively if you've already done the check at the admission controller point. I think this would actually be very trivial to put in place. And if people are concerned about it, and there's a way to lock down that image so there's no race condition there, then it would be better.
I think the best we can do is like a SHA-256, reference to the image content, which I believe, unless you're a nation state, is good enough.
No, I think the thing I'm worried about though is, I think SHA-256 is used by default in a reference implementation, but the problem I think we're more worried about is, what if, so TUF is going to go check, and then after it checks, you'll instantiate. But what if between those two times, they're able to overwrite it? So that's why if you can make it immutable make the file, the image immutable or something like that, then that prevents that race.
Basically sign the pod manifest in
or there's something,
specifies which image.
Yeah, but there's something even on the file system you can do where there's an immutable bit, an immutable linkage invert bit, and an immutable bit. Do you know about those in the
Yeah, that's probably going to break too many people's things.
Okay, but if that image shouldn't be written to at the time, then setting that in on the file system for that before you execute it will make it so that, because effectively the only way you can unset that bit is if you have like very privileged kernel access to do so. And so and it's not a hard thing to set. Actually, the thing I wrote something called Stork back in like 2002 or something that was like the first package manager that anybody was using in these like OSVM environments. And this used that mechanism a little later on. I think we did it in like 2004, 2005 or something like that. But it still exists. You can go and you can set files so that even root can't remove them unless root goes in and unsets this special bit on the file, like an adder thing. It's something to think about. I'd be really happy to sit and try this out. I don't think it should break things, assuming images are not supposed to change while they're running, which I don't think they are.
I don't think, I'd have to check with some of the runtime people exactly what the mechanism is. I guess that's one of the other things, is that's technically outside of the Kubernetes world. And since the interface now is there's the runtime interface, and there are a multitude of operating systems that you can be running with different settings, with different network plugins, with a million different plugins you can have. So
yeah, I think this only will work on Linux, but I think there's something semi-equivalent on Windows. I don't know if Mac has. I haven't looked at the file attribute flags very closely on Mac, but they do support this and have some interesting.
Right,
flags.
we just don't have any way to enforce it at least at the Kubernetes ecosystem level.
Okay.
I don't think.
Okay, yeah, but I'd be happy to follow up about this if you want to have a conversation with somebody and want me involved, or just want to talk with me about this. Like, if you want to figure out what to say to the folks at that interface, then I'd be happy to chat more.
Sure, I'll follow up if I have questions on that. There's actually the supply chain within Kubernetes has actually kind of two angles. There's the distribution of Kubernetes itself, which I don't know if anyone has done anything about. Do you know of anyone who's looked into that?
You're talking to me?
Yeah, I'm just trying to thinking out loud, maybe.
No, I'm not at all aware of that. But maybe then, yeah, I think something should be done with that, and I'd be happy to talk a few minutes about in toto if that's a good segue into it.
Sure, yeah, let's segue into that.
Okay, great. So if Howard, if you want to share screen again, this might be a little easier with a diagram for me to talk through this.
I think I can share my screen.
Okay.
Present. Well, no. Where do where's the button for that? Oh, there we go. Sure. Oops.
Yep, that's okay. That's fine. Yeah, so just go back a couple. Actually, you can go forward a couple slides. We don't have to. There's a lot of animation here. Okay, this one's
nice.
Yeah. So basically, what this is trying to do. Oh, hold on. Just settle somewhere where it has like that. Not the press clip. and I'll talk through it. Sorry about that.
This one?
Yeah, that's perfect. Just stay here for a moment. Okay. So yeah, you recognize this. This is at least one way people make software. Actual real software supply chains have many more steps in them often, but it's, you write code, you do some linting on it, you build it, you have some CI/CD system that probably also does some testing. You package it, you do all kinds of other localization and testing and other stuff like that. But in the end, you make software. And fundamentally what happens today is attackers that break in on any of these steps can go and effectively manipulate the end software that's produced and add, backdoors, do all kinds of crazy stuff. And all of those like myriad of annoying press things that you've been going through are high profile examples of that. So go ahead and go forward a couple more slides. Just like blow through this until we, go ahead, go forward through there. All right, and go forward through that.
Yeah.
Okay, so go back, or actually, this is fine. So basically, people can go and hack all these different sorts of places in the supply chain. And there's little point solutions here. So there you can do signing for your repo. Actually, the mechanism that Git now uses for signing is one that Santiago Santiago's the main student who's worked with me on InPhoto, upstreamed into Git in September of 2016.
I didn't know that. That's awesome.
Yeah, we're trying to get more of our changes in. We're trying to turn their dog into a cat, and it's still kind of works a bit at times, but it's better than it was before for sure. And then we've also go ahead and just one click forward. Oh no, keep going through this until you get to the next thing.
There we go.
Yeah. Okay. So we've also now there's a lot of good solutions at the build stage. So we've been working with reproducible builds for a few years now. They're a great community, by the way, Erica. I don't know if you ever have been that interested in it or something, but we go to their conferences and hang out with the folks there and stuff. They're a real fun group. A lot of folks from a lot of different open source projects. So Erica Howard, if you guys are looking for something fun to do, reproducible builds is a good community. And then also, in addition, go ahead and go forward a few more. So as you know, we've also, from what we've been talking about, we've also been very involved with, in developing things for TUF, for handling this last piece. Go ahead and go until you get back to the sort of diagram-ish thing. Yeah. Okay. Okay. So yeah, go. Yeah. So here. So and also, and also, even if you just have all those point solutions, it actually doesn't really solve the problem, because you want to know more than just the repository did signing on commits and sign tags, and the build system built something reproducibly. You want to know things like, was the thing that the build system built a signed tag from the VCS? And was the thing that was built by the build system the thing that got packaged, right? And then got distributed to me. You don't just want to know, did one step of the process go okay? You want to know, did they all go okay? And did the things that made it through the steps go through, the thing you ended up with, did it go through all the steps in between? Did it pass the unit tests? Was it the thing that was actually verified and validated? Right? Does that make sense?
Yep.
Okay. So that's what InToto does. So next slide. All right. Yeah. So we're going to verifiably create metadata about all the steps of what we call the software supply chain, the different steps that happen there. Have a way to verify that the people who perform those actions are correct actors, and make sure that there aren't extra things stuck into software, steps aren't skipped, tests aren't missed, so on.
Is the authorization basically on the keys, whose key?
Yeah, go to the next slide, and I think I can explain a little more clearly here. Yeah, so, okay. There's a file called a layout file. And the layout file defines who all of the parties are, what steps those parties perform, and how the steps connect together. Okay, so the layout, which Alice, who's our project owner here, has signed, says, Bob is the one who's control of our VCS, Carol does our build system, Dave, runs testing infrastructure, and Aaron does the actual packaging. And it says what their keys are and what things they do in those steps. And also says things like, when Bob tags a release, Dave is testing tagged releases from Bob. Carol is testing tagged releases from Bob. And also, that when this all goes together, that the same tag that Bob, the same tagged version of the VCS that Bob had has to be the one that Dave and Carol both refer to. So the tests from Dave have to match the same version that Carol went and built, and that has to match what got put into the package that Aaron built, and all of this has to match what gets delivered to the end user. So it links all of this together, like links in a chain. Okay, and then when the individual parties go and actually run their steps, they go and they actually create pieces of signed metadata called link metadata, like links in a chain, once again, for the different steps that they do. And then go ahead, next slide. Yeah, and then the end user receives the package, the layout, and all the link metadata that went into it. And the end user goes through and does a process called verification. And verification, you can think of it in like the most obvious thing it does is it checks, if the layout says that, hey, the output of this step goes into the next step and so on, it checks all those other things. But it also can have the end user run commands to do things. So for instance, the end user may go and unpack a package. And then after the end user unpacks the package, they can check that after they uncompress the files in the package, the files that they get on their disk are the same files that the person who built the package put in, right? Because there's been a whole host of different vulnerabilities related to things like buffer overflows in decompression programs and stuff like this. There's a ton of them historically.
Yeah.
So we can just sidestep all of those sorts of issues and have the client, have the end user, or really have anybody in the process verify and verify things throughout the steps that they perform. Okay, so does that make sense?
Yeah. Let's see.
Okay. Yeah, the rest of it's going to be detailed, like more detailed than you probably want.
Actually, this might be something we want. For instance, the project owner, do you generally, how many levels of delegation do you typically see?
That's a great question. That's a pro question. Okay. So first of all, you can have levels of delegation, which I didn't say before because I was keeping it simple. But you can have any number of levels of delegation you want, including you can have what are called sub-layouts. So Alice can say, I don't want to say, like Bob, who manages VCS, I don't want to tell him, or maybe that's not as great of an example, like Carol, who does the build system, I want to give Carol the flexibility to do all kinds of things in the build system. Maybe she's doing reproducible builds and she wants to be able to swap out who the reproducers are and other stuff like that. Or you can even say things like a library that I'm building has to have valid in-toto metadata in order for me to include it in the thing I'm using, right? And so you can have this sort of sub-layout thing that nests these multiple layers deep. And some of the folks that have deployed in-toto actually use this, the sub-nesting. So it sort of depends. Like you can get a long way without it if your organization's fairly flat, like you have a common build system that everybody uses and is well known, and you sort of know who your developers are and they're only building specific things and so on. But if you're like, but it supports much more complicated use cases.
Can you decouple the layout or sort of the policy definition from the applying it to the artifacts? Is that possible?
Can you say a little more?
So for instance, like there's a threshold, right? That's defined.
You can use threshold, yeah.
And so if it was set to 3 and the whole package is signed and everything, and then someone with the appropriate permission wants to change it to 2, can they retroactively kind of do that? Is there a way to say that these people have the ability to change parts of what we're requiring separate from the people who are verifying the step? Does that make sense?
I'm a little lost with the question about verification, because the people who do verification use the layout to be told what to do to verify. You can, if you are the project owner, say things like Carol is able to select how this gets built. And you can also say things like Carol and Sarah and Jolene are able to do it. And you can even say things like they're able to decide, they can do things like say, cut out one of the participants and do other stuff like that with threshold signatures. If that's what you're talking about. Are you talking about kind of like a key rotation sort of thing, independent of the project owner?
Well, I'm thinking about usually a lot of the sort of the policies of like what they want to allow or not allow is usually defined by administrators at some point, independently of the verification happening. Does that kind of make sense?
So you're asking, like, could a separate security group, for instance, set policies that got embedded in here and checked?
And that got recalculated.
Is that another way to phrase it?
Yeah, sort of. And could they be kind of like recalculated or compared?
I can't hear you. I think.
Yeah, no.
Are you there?
I guess how much can they be recalculated? If are some policies?
Hello.
Are some of policies relevant subsets?
I hear no audio.
Oh. Can you hear me?
Can you hear me?
Can you hear me?
Yeah.
Hello?
Howard, can you hear me?
I can hear you. Justin, can you hear me?
Yeah.
Okay, it's back. I hear things now.
Okay.
I don't know. I don't know what happened there, but.
Okay.
Okay, so sorry. So are you basically asking a question of, can you have somebody separate define parts of how you do your verification from how you set up your like somebody other than Alice define parts of that? Is that the question?
Kind of, yeah. So yeah. So there's sort of a mix of someone can sign and verify that this is a commit that happened or that this came from here. But then there's kind of the policy aspect of it is, and this is the kind of like the thresholds, and these are the people that are required. And those seem like they could be more dynamically changed.
So, okay, hold on. So yeah, I see part of what you're saying. You can define, you can, I think I'd have to see an exact example, but I will say that you can decouple parts of the verification from other parts using sub-layouts. And I believe you can do things like let people rotate out keys and do other stuff like this without letting them, like, change what like version control they're using or whatever else. So I think it's entirely possible to do something like what you described, but I would really love to have an exact, like just an example, and then we can go and produce in toto metadata that shows it, or tell you why it doesn't work in toto. But I'm probably like 80% sure what you are thinking of here can be done, because we support things that are much like it. I'm just a little confused on some of the specifics.
Yeah, I suppose like revocation is a sort of dynamic policy change that you deal with. Is that correct?
Yeah, exactly. Mm-hmm.
So maybe how does the revocation work?
So it depends on who revokes what and how this works. So if you have a sub layout, or you have, so if you just have signed something you wish you didn't sign, or you, someone has had their key compromised, then the person who delegated to them changes whatever file that is. So that's a layout or a sub layout is the way in which this happens. They change this, then there's a new version of this file, and then this file gets distributed. It depends on who, the in toto deployment, about how they do this. Some of them bundle in toto metadata inside of TUF. Some distribute it separately, or bundle it along with the software they distribute. You can do any of these ways of doing it. It works. But in the end, you end up receiving the, if you use TUF, you get verification that you're receiving up-to-date metadata. Otherwise, the mechanism you're using for distribution has to provide that. And then once you get that, then that will have the changed project owner layout or sub layout that then indicates what the new key is, effectively revoking the old one.
Okay, I think I see. I'll have to think about how it fits in.
Yeah, it might be easier to think about it how it works in TUF and then translate that, because in TUF, basically for targets metadata, which is your way of pointing to the image or the piece of software you want to download, there's a file that gets signed that will either delegate to other targets files, or will flat out list hashes of things that it's delegating to. So you can sub-delegate in that way, or you can list hashes. And to remove your trust in something, to revoke like a delegation that you yourself have performed, or to stop saying that a specific package that was built is trustworthy, you just remove it from your targets file and upload a new one. And any client that goes and retrieves your targets file ends up retrieving an updated version that has that trust delegation removed. So it effectively is a mechanism for going and removing trust in that manner. And in toto is basically the same.
I know that Optane deals with the time server. Is that part of the TUF spec, or is that in addition?
The time server is not part of the TUF spec. The time server is needed inside of Optane, or at least it's useful for some Optane deployments, because in Optane, the nodes don't have a way to know what time is, because in cars, like little embedded computers they have there don't have like a clock or anything. So the time server is like a cheat to make something like that happen. if that makes sense.
Yeah, that makes sense. But otherwise, you would consider the system clocks usually good enough.
Yeah, they get used along with the way the timestamp role works inside of TUF. So usually that's good enough for other domains.
Okay. Howard, do you have any other questions? I feel like I've probably been taking up all the time.
Yeah, I was thinking something like in machine learning, I think the supply chain concept could be also applied because the pipeline is very similar, right? If I want to like serve a model, I certainly, as a user, I want to like know for sure the whole pipeline of like getting that model could be verified. It's very similar to the supply chain, right?
Yeah, I think there's also like some newer services that are dealing with model distribution. That's a cool area. Do you know of anyone who's looked into model supply chain security?
Yeah. Justin?
I worry. Yeah, go ahead.
Yeah. No. That was the question. So, like any people talk to guys about the machine learning supply chain or pipeline security?
I've heard people talk about it, but so I'll give you my personal opinion, warranted or not, but I'm a little skeptical. I think they'll be able to catch some of the really low hanging fruit, but I really doubt they'll do better than this is not the type of problem that I feel machine learning is going to be particularly excellent at, unless it's over not having anything. Because in many cases,
I think we're asking about the reverse.
Uh-huh.
Using TUF to secure machine learning, not machine learning.
Yeah. That'll work just fine. TUF can secure whatever information you want to distribute. Sorry about that.
Has anyone come forward and talked about that with TUF?
We have had questions that relate to that, yes. But I'm not aware of anybody who's doing that like large scale in production, but we have had people ask that question before. Yeah.
So back to the like intersection with policy. So are you seeing like people can in a declarative way to like deploy a policy regarding the TUF framework, like through Notary, what kind of signing mechanism I want to impose or other stuff.
So, sorry, I heard most of that. I think you're asking, have people used like a declarative language to define TUF rules and things? Is that the question?
Yeah. Is there a way, or if not, is there a plan to support like a declarative way of doing
that? That's an interesting thought. It hasn't been something that's been requested. I think I'd need to see a broader write-up about what that would look like and what that would enable beyond what we already do. But it's an interesting thought.
Cool. So last question from me. What is the best way to participate in the discussion from TUF or Optane or Notary?
Yeah, so TUF, Optane, Notary, and Toto. We have it depends on the level of engagement or what you want to do. We have mailing lists for all these projects, and they're all fairly active. Also, the issue tracker, if you have like a specific request or something, is not a bad thing to do. And really, anybody can also just email me, jcappos, JCAPPOS, at nyu.edu. And I'm happy to also then CC in whatever groups are appropriate for whatever the query is.
Okay, cool. Are you also like live on Twitter or something? People could.
Sorry, one more time.
Are you on? Do you Twitter or any of the other?
I am on no social networks at all.
Good.
Yeah.
Yes.
I have basically stopped going on Twitter. It's definitely not worth it.
Okay, that'll be all from my side.
Should be the same.
Thank you so much for talking with us. I think.
Sure, yeah, and I'm happy to talk more if any other questions or thoughts or things come up. So yeah, nice meeting you, Howard, and great talking with you again, Erica.
Yeah, I'd love to see more momentum on some of these issues in Kubernetes. But
sure, well, just let me know what I can do to help.
Awesome. Thank you so much.
All right, thank you both. Bye.
Okay, bye.